Hello, dear Tivisha. How are you?
Hello, sir. I'm fine, sir.
Okay. How was your day today?
It was good.
Okay. So let's get started with our class. We were studying the and forces, its formula, and different terminologies related to it. And we have started it from the yesterday class onward. So we have learned some of the basics of the related to the force. So, in order to understand the force completely, we need to understand some of its terminologies. We call it terminologies or the scientific terms, which will be very helpful for us to understand the physics, like force, pressure, area, etc., thrust. So we begin with the definition of the force. Then we say force is a physical quantity when it is applied to an object. It tends to or even can move the state of rest to motion. Then we begin to understand the mathematical formula. Force is equal to mass into acceleration. So we need now not to emphasize or focus on this particular formula. Let's first understand what is the role of mass and acceleration in the force. So for that we have understood what mass is actually, where we understood the mass is the number or the amount of constituent particles present inside the atom. What is constituent particle? Constituent particle is the particles by which of which our atom is formed or is made up of. Like in case of water, it was H2. In case of we can say human, human are formed of, the basic building block, that is the cell. So when we need to find out the mass of human, so we need to count or uh, measure the amount of cell present in the human body. That is it. Thereafter, we understood the difference between mass and weight of an object. We understood mass as the number of amount of particles, constituent particles sophisticatedly present inside the matter, and weight is mass along with the gravitational force exerted by that particular mass. Weight is measurement of mass and multiplied by the gravitational force exerted by that mass. So not weight weight is not weight is also related to mass, but something extra in the weight is that it is also related to the gravity. Or if there is no mass, so how can we say that one object will be attracted by the another object, right? There is no role of gravity, isn't it? So
Yes, sir.
if it is a massless, then there is no role of gravity, and we cannot say, then we say it is a weightless quantity. So it is related to mass, but as well as gravity. How much force, a strong force by the gravity that has been attracting that particular mass. So we also understood we distinguish these two particular things, that is mass and weight. So definition of the mass is amount of matter, constant particle present in the body, or weight is the gravitational force acting upon that particular mass. So weight is an scalar quantity, mass is an scalar quantity, while the weight is in vector quantity. Now let's understand a little bit of the scalar and vector quantity. So scalar quantities are those who don't have any direction, or vector quantities are those who have direction. That is the basic difference. If I say where does Tivisha lives, so I typically need to point towards any direction. Suppose you lives right there, and somebody ask me where Tivisha lives. Okay, so I need to point towards any particular direction. Like if suppose it is in east, so I would say Tevisa lives in the east direction. So this becomes a vector quantity. And if I say like uh, uh, mm, okay, I'm currently not able to recall the example of the weightless directionless thing. Okay, like the mass itself, mass is weightless. So there is no direction related to the constant particle inside that particular atom. Or we can again understand that if this is an earth and this is a person above the earth, so the earth will pull that particular person towards the center of the earth. So this will become the direction of that particular gravitation. So that's it, vector and scalar quantity. So vector quantities are those who has direction like the weight, because earth gravitational act in a particular direction. It is downward, upward, whether it generally downward. But if there is some extra weight, heavy weight than earth, it could be upward. Mass is in a unitless quantity. Now we also understood the unit for that. Mass for that is a kilogram, gram, and weight is the Newton, because it is the measurement of the force by the body of particular mass, then it must be Newton. Then we understood why the wave machine, even measuring the amount, the force, gravitational force we applied on earth, still shows it in kilogram, because it basically divides that particular reading by the wave machine divided by 9.8 meter per second, which is in standard g force. Then it gives it into kilograms. Thereafter we understood which one is an easy, in order to understand what is the role of mass in particular in force. So we understood that kicking a 5 kg ball will require less force as compared to the kicking 10 kg ball. And then we can say that force has direct relation with the mass. If we, for little weight, it requires less force. For greater weight, it requires more force. So we can say it has a direct relation. So now we know F must be equals to M. And the next term that comes in the force is the acceleration. To understand what acceleration is, we need to understand some of the key terms. I know this is, we can say, a little bit extra deeper, but this is the only thing we need to understand about the force. If you only know force is a kind of a push pull, which is not a standard level definition or a good understanding of the force. So nonetheless, let's move on to the displacement. We understood if it is you at the position A and this is B, your house at the position B, and this is C, the place where you wish to go. So suppose I am at the place C and you are at the place A, and I ordered to you to come to me. So there are two possible way you can come to me, that you travel from A to C and you travel by 5 meters. And there comes another thing in your mind, then you thought that I go home traveling 4 meter, I will eat there and then I will go to me and traveling by 7 kilometer. So if I calculate the displacement when you come to me, then I would say it must be 5 meter. I will calculate the nearest possible, closest possible distance between the two particular point, irrespective of the how much distance you have covered. So that is displacement. That is the basic difference between displacement. It is a vector quantity, so it also has direction. Like if I show you in this particular, so this plane is flying, but in the east direction. So it has, we can say, displacement, but in the east direction. Hence, it is a vector quantity, meaning it has a direction. So it only depends upon the initial and final position, and it do not depends upon the path. If I need to calculate what is your displacement, so I will mathematically subtract your final position, that is to me C, from your initial position, that is A, and this will ultimately by default give the shortest possible route. And it can be 0 even if the distance is not 0. Let's understand how it can be 0. Suppose you traveled from A to C, 5 kilometer, 5 meter, and then you travel from C to A. Again 5 meter, total of 10 meter, right? So your distance, the distance you travel is 10 meter. But the displacement, you traveled from here to particular point C. Let's consider it positive displacement, that is 5 meter. Again, you come from particular point C to A, it will be negative displacement, that is minus 5 meter. So that overall displacement will get cancelled out and total displacement will become 0. And we can understand this particular thing like this. So you travel from A to C and again you come back to their original position. So there is no displacement at all. Although there is distance you covered, which is the 10 centimeter. Hope you understand the displacement and the distance. Now here
Yes,
comes
sir.
another thing, that is velocity. Thereafter we will be understanding what is acceleration. Then we are ready to understand what a force is. But prior to that, I want to say that you can keep a very short note of things. Like when I read something, so I usually associate, categorize things into different part, and one part is none other than the hardcore data. Like for easy example, you can forget who was the Prime Minister of India in 1935 because this is just an hardcore data. There is no logic associated with it. So in between class, anywhere you find the data, the concept, you would likely to forget. So you can keep a simple gist of just 2-3 pages. So you can take, you can keep your pen and paper together with you. So we are ready to go to understand velocity. Any question you want to ask?
No, sir.
Okay. Is this class becoming heavy?
No, sir.
Okay, okay. So let's understand now velocity. What is a velocity? Suppose you are moving. So suppose you are driving a scooty and I'm in your invigilator. I'm one who train you, teach you how to drive a scooty. So I am just having two eyes. One eye at your scooter playing or second eye on my watch. So I am observing that in how much time, how much distance you travel. Like in 1 second you travel 1 meter, 2 seconds you travel another 2 meter, 3 seconds you travel another 3 seconds. So here are two things. One is your displacement, another thing is my time. So I am observing two things. That is your displacement and with respect to time, and we call it velocity. So velocity is basically displacement of an object with respect to time. When we observe our watch and somebody's movement, we call it velocity. Velocity is the change in the displacement with respect to time. So how much did Tivisha had traveled in particular 1 second? So it must be d upon t, basically means distance per time, and the unit distance we know we measure it in meter, and time we know we measure it second. So this is in standard m upon s. Meter per second is the unit of the velocity. We understood what velocity is, right? Now let's understand acceleration. So acceleration, now let us consider another hypothetical example. So again, you have a ball, let's say 5 kg, and you have a same ball 5 kg, and you have to kick it to the goal post. And here are two conditions. In the first case, I, as your coach, suggest you to kick that particular ball in 10 seconds. In the next time, I suggest you, I order to you, kick that particular ball in 5 seconds. Now you tell me what, how, and what will you do to perform these particular activities, meaning kicking the ball in 5-10 seconds and in 5 seconds.
So maybe I'll run back first. Miss in the sir, in the text 10 second ball, I'll run back first and then come in 10 seconds and kick the ball as hard as I can to and aim it properly. And in the 5 second ball, I'll do the same, but I'll not go that far. I will not that force.
Okay, you want to kick in 5 seconds, but you will not kick so fast. Are you sure for that? You have to
So
kick the
like
football.
lesser than the 10 second one. Lesser than the 10 second one because we don't have that time at that time.
So
So
you have to kick that particular football in less time. So you must need you need to apply greater force, isn't it?
Yes, sir.
Greater force with the greater distance. As you are going backward, so you have to travel a little bit longer in case of you want to kick it in 5 seconds. I mean, the time will be counted from where you kicked the football, not you traveled backward or
Okay.
forward. This time will
Okay.
not be counted. The time will
Okay.
be counted from the moment you kick the football and it goes to the ball post. So if you need to kick the football into 5 seconds, you have to apply greater force. So it travels within that particular span of time. So in 10 seconds, you will kick like this. Okay. So for 5 seconds, you will kick with the greater force. Okay. This, like this. Okay. So we understood. So in the second case, what we did, basically, we tried greater force and that greater force only to increase the acceleration. So now let us consider another example. Velocities is what? Suppose you are riding a scooty and you have a fixed time. So you are riding it 20 miles or kilometer per hour. So you can travel 20 kilometer in 1 hour and you have to travel, let's say 80 kilometers. So how much time will it take?
4 hours.
4 hours. Okay. Now, in one case, you travel your scooty, you start your scooty by 20 kilometer per hour, and in every point of that particular path, your velocity remains same. That is 20 meter per hour. But this is in hypothetical case, right? When we actually ride the scooty or bicycle, we have to face different type of obstacle. Like suddenly a grandmother comes in just front of us, so we have to apply a brake. So we need to reduce our velocity and we will reduce it to zero. That then only the scooty will be stopped. So the grandma can pass. Then thereafter we have to push the accelerate, apply the acceleration, and we have to go from 0 to again 20 second. And remember, we have wasted some amount of time in between that. To utilize that, we have to apply a little bit greater force, greater acceleration. So we typically need to go between 60 to 80 kilometer. This is what we called acceleration. Now what happened? When you applied brake, your velocity becomes zero. This is a reduce in velocity. That is acceleration. Reduce in acceleration. And we apply acceleration again. Your velocity from 0 to reach 60. This is increase in speed. With respect to time, this is increase in your acceleration. Okay, so we are ready to go to understand what acceleration is basically. So acceleration is basically change in velocity with respect to time. We understood if you are going to apply brake, your speed from 40 to 0, and we are also measuring this again with respect to the time. And when again the grandma passes, you have to apply the acceleration and you have to reach 0 to again 60. So this is increase in acceleration. So acceleration is basically change in velocity with respect to time. So acceleration becomes velocity upon time. We know what is the unit of velocity. It is meter per second, right?
Yes, sir.
Again, we are measuring that velocity with respect to time. So we have to multiply the time, unit of time, that is second. Again, this will become meter per second square. It is sometimes written as meter second power raised to minus 2. I hope you understood the basic displacement, velocity, and acceleration. Now we are ready to go and understand the force. What force is? So this is 10, 10, 5 second or 10-second scenario. You need to kick the football. So you just need to apply greater acceleration to that particular force, or we can say to get high acceleration. So the ball will reach within 5 seconds only when we apply high acceleration. And how will we apply that high acceleration? Only when we will apply greater force. So again, we know acceleration and force has a direct relation. We apply greater force, high acceleration. We apply less force, less acceleration. Now we are ready to understand what force is. So we know by default till now the acceleration, the force must be the product of mass and acceleration. And since these are the things which has direct relation with the force. And I suppose you will now from onward never will forget what force is basically. Will you?
No, sir.
Okay. So my idea is when you understand concept, there is no case you forgot them, although you can forgot some of the data or some of the things which include data plus concept. So for that, you can keep a separate note, simple gist of 2 3 lines in particular lecture. Now we are ready to go understand the speed. Speed is exactly same as that of the velocity, but only difference it don't have any direction. Meaning it is a directionless thing. Distance covered in a particular time. So if this plane is flying and we don't mention any direction, so this will be its speed, like 20 miles per hour or 20 kilometer per hour. If we are mentioning the direction as well, like we are saying the plane is flying 20 miles per hour in the east direction, so we are referring to velocity. So that is it. We usually say in generally we say the car is traveling by 20 kilometer per hour, so we are referring to speed, not the velocity. Now let's understand what is the case, the rest or motion of an object. Here comes another thing which is called the law of inertia. Inertia literally means which don't like to be changed, right? So there are sometimes the state of our mind also we don't like to change and we are very afraid of the changes around us within ourselves, don't we? What do you think?
Yes, sir.
So sometimes it becomes things becomes worse and it put some anxiety on us that with the changing thing, but that is a hard truth. Things are always kept on changing. So inertia basically means things which don't like to change itself. So in physics, generally inertia means the state if it is in motion that in it wants to remain in motion, or if it is in rest it wants to remain in rest. That is basically inertia. Now we looked on to our solar system and we know there is sun at the center and there are planet around it which rotates with various speeds, different type of the planet with which rotates in the different speed. Now the question is, why do these planet rotates? Any idea, any
Uh,
guesses?
so because they have to, like they cause the day and night,
Yeah, they
the
cause
rotation
day
of the
and
planets.
night. That's because of their rotation and revolution. They are performing two kind of motion. Rotating in their axis, we call it rotation, and rotating in a circular path, we call it rotation. My question was, what was the force? If they are moving, they must have some kind of energy. There must be some of the forces applying on that particular object. My question is, do you know or you have any idea of what the force exactly behind the rotation and revolution of this particular planet? I mean, who is the person who is rotating it, whether it is God or something else? What say?
So in science, it's obviously not God, but in
Okay.
mythology, it's God.
Do you believe in God?
So no idea. God is there, but science has different definitions.
Okay. You can forget, apart from the science in general trend, general speaking, do you believe God or some in mythology, whatever you can say, spirituality? Do you believe that? You a
I like
spiritual and you
reading.
are
I I like reading about like these type kinds of stories or books or some famous story that happened in the past, which is related to some god.
okay, that's good. But you have you don't believe that there is some person like this with four hand. Someday it will apparently appear in front of you and ask Tavisha, what is your wishes? I will complete it. Okay, that's very good. Not
Nothing will happen like this, but there is God. Like somewhere he is there.
okay. You believe that there is some divine force that regulating the universe, and
Yes, sir.
that is God.
Some
With
positive energy is there.
okay. So that is basically good idea. Not believing easily means there is a chance that you someday you might reach to that particular position, or you might discover the God. So nonetheless, we are understanding what is the force behind these particular planet to rotate and revolve. They perform two type of motion. They are rotating and they are revolving. We know if they has motion, generally we know there must be a force. In general cases, if there is an object, we hit that particular object, so it rotates. So due to that, on this particular understanding, we can also think of that if these particular planet are rotating, so they must have we can say force applying in on it. So the force due to they are rotating is the gravitational force and the inertia. So the primary force for these particular bodies they are rotating is inertia. They are in continuous rotation from the time where they have been formed. And I stated in the law of inertia that any object, whether they are in motion or whether they are in rest, so they don't want to change their state. If they are in motion, so they will remain continuously in that particular motion, or if in they are in rest, so they will be remain rest. So the object like in earth, like this glass cage, it is in rest and it will remain in rest. And these planet these are in continuously rotation, so they will remain in rotation. Now another question is that the inertia is for the straight line, meaning motion must be in the straight line. The basic idea of the inertia is they must be in the straight line. But why these planets are moving in the circular, we can say parabolic type of the path, orbital shape? So the answer is this is particular sun at the center, which is applying the gravitational force. That's why they are all planet are binding towards the sun. This particular planet wanted to rotate in the straight line, but it was attracted by the sun, so its direction suddenly changes a little bit, and so it becomes a kind of we can say parabolic or a circular type of motion. So the reason behind their circular motion is inertia as well as gravitational force, and the reason solely behind their motion is the answer is inertia. So we understood the idea of inertia and rest and motion, which is the basic idea of the rest or motion of an object in that particular on uh, that particular thing. So now let's understand effect of forces. That is what if the force is applied, what they can do. So are you tired? You got tired? Should we continue?
No, sir.
Okay, that's
We
good.
can continue.
So tell me when you are getting bored or a little bit tired, so we can have a little bit pause or can say interval into that. So nonetheless, let's move on to understanding effect of the forces. So when we apply the force, so its speed can be changes, and it is very obvious thing, right? When we kick, so the football is coming from opposite direction and we are in the opposite team. So we have to kick that particular football into the opposite direction to reach that particular goal. So we can, by kicking, change the direction of the speed of that particular force, and we also can change the direction of the speed. So if this is an object, if we apply force in the upward direction, if suppose this is in motion towards uh, uh, downward, and we are applying opposite force, and we have applied greater than the downward force, so that the downward cancel and the remaining force push this particular object into the upward movement. And this is also an obvious thing, not hard to understand. Now effect of force, it can change a shape also. So you might have seen the LPG, liquefied petroleum gas, which is used in cooking in generally in India. So if you have closely seen in lighters, it is in liquefied form. But if you press the button, it releases, it becomes gas. So there was a video on the internet in shorts that somebody is claiming that in that particular gas cylinders, the liquid has been filled. So he don't have any idea of the liquefying gas. LPG itself means liquefied petroleum gas. So the gas have been applying force compressed into the different compressed into the particles get closer and it was compressed into the liquid thing. Apart from that, we can also consider a case, the spring. Usually we like to play with it. So when we press it, it becomes smaller, or when we stick some particular suspend a particular ball, so it will become larger. So we have successfully changes its shape. So that is also very important thing. Now a last important thing of the class is density. So this is also another technical thing we need to understand very, very clearly, because in the higher classes you will be encountering these particular term velocity, density, acceleration, speed, etc. numerous times. So if you don't have the exact understanding of these terminologies, you will misunderstood these concepts. So now let's understand what a volume is. Volume is space occupied in object, and this is a three-dimensional thing. Meaning we remember the formula of the volume, which is the
Length into breadth.
cube. For a basic cuboid, you can say, what is the formula for the volume of a cube? Have you been taught this particular 3D geometry in your school?
Yes, sir.
Okay.
So basically, volume is something which is contained inside, and I think it should be length into breadth
Into height.
into height. Okay.
Good try. Okay, so we measure three dimension. So suppose this is in cuboidal, although it is cube. Suppose it is in cuboidal. That is the science of beauty of science. So we can imagine anything. So we have to measure the length and the breadth and the height. So total there are three dimensions: length, breadth, and height. That's why we call this particular object a 3D, three-dimensional object. And the unit for this particular thing will be meter. We usually measure the length in meter, breadth also we measure in meter, then height also we measure it in meter. So meter multiply meter will become meter cube, right? So for
Yes, sir.
any square, rectangle, these objects are 2D shape, like square and rectangle. So what is the area of rectangle? Can you recall?
Yes, sir. The area of rectangle is length into breadth.
Okay, what will be the unit of the rectangle? Can you form?
M into M
M into
square.
M square. That's great. And we call it 2D object. Why? Because you are measuring it in two direction. That is the length and that then the breadth. So we have understood the volume, and now it comes a little bit confusing term, which is density. We confuse this particular term with the mass, sometime with the volume, but there are some of the basic differences as well. So density basically means, forget this. Now let's have a look on this particular object. So we are going to make a cube or cube of 1 meter length, 1 meter height, and 1 meter breadth, right? So 1 meter length, 1 meter height, and 1 meter breadth. And if we are successfully made this particular cube, we call it unit cube. Or since L, that is length, breadth into height multiply makes a volume, and it has 1 meter, so we can call it unit volume, isn't it?
Yes, sir.
So density basically mass into that particular unit volume. So it is not mass into the entire shell. Suppose this is in big bricks, we are measuring the density. So if you are going to measure the density of this particular brick, so we need to apply onto 1 meter length, 1 meter height, and 1 meter breadth, and onto the small part of this particular thing. And then we need to calculate the mass, and we know what is mass. Mass is the number of constituent particle inside that 1 meter, 1 meter, 1 meter. So this is basically density. Density is not related to the entire object, although we can calculate the average density of particular object. So the density becomes mass divided by volume. Now can you construct the unit for the density? You know the density of mass and you also know density unit of volume.
Density of mass.
No,
Mass.
sorry, unit of mass.
Sorry. Unit of mass is kg and volume is meters.
Cube.
So, density is equals to kg divided by meters, meter
Meter.
cube.
Okay. So we successfully have understood the density, and this was the last topic of the today's class. And now let's end. Anything you want to ask?
No, sir.
Okay, so we will meet on the very next class. Let's end this particular class. This class was fantastic. Thank you. Have a great day.
Thank you, sir.
Okay.